go through this one. So let's look at the first one. I'm going to call this one A. Okay, so if I've got x, then 2x plus 1, and this is what I want to derive, so this is equal to y. So the derivative of this is going to be given by, firstly, I can see two functions which are multiplied together, so I can use a product rule, right? I can use the product rule, which means I would have to definitely remember that first. So if I've got a function which is going to be given as I is equal to ab, the derivative is given by a dash b plus ab dash using the product rule of derivative. So if this is going to be that, then I need to derive one, not derive the other. So let's derive x, it'll be 1, and then not derive the other, so it'll be ln 2x plus 1, and then plus, keep that, and derive this function. Now when I derive that function, it'll become 1 over 2x plus 1 multiplied by the derivative of the inside, which is 2. So 1 times 2 in the numerator. Yes, it'll be times 2 there. The derivative of this will be ln 2x plus 1 plus 2x divided by 2x plus 1. Okay. We could then find a common denominator, or we could just stop there as well. The next one what we got here is we've got the quotient rule, which is coming out here. So derive using quotient rule. So the quotient rule has the following calculation, which is basically if you've got y is equal to a over b, then the derivative will be given by firstly taking the derivative of the numerator times the original of the denominator minus the original of the numerator times the derivative of the denominator, all divided by the denominator squared. So for b, what we have is y is equal to ln 5x over x. And if that's a and that's b, and I apply that formula, then the derivative is going to have, firstly, let's calculate the derivative of the top part first. This is going to be 5 over 5x, because 1 over 5x times 5 times the derivative of x. The derivative of b is the derivative of, it's supposed to be x. It's supposed to be x. Be 1. Alright, so that's going to be x. Let me just remove the 5 there. The derivative of b is equal to 1. Now I've got all the tools, it's just about substituting it very carefully. So I'm going to put derivative a times b. So that's 5 over 5x, which can become, by the way, 1 over x, right? 5 over 5x is 1 over x. The 5 will cancel. Alright, so 1 over 5x multiplied by the derivative of 5x, which is 5, becomes 1 over x. And I'm going to have 1 over x multiplied by b, which is going to be equal to just x, minus a, which is ln 5x, multiplied by the derivative of b, which is 1, all divided by b squared, which is x squared. That becomes 1 minus ln 5x divided by x squared, and that would be the final derivative of it in one go. Let's have a look at the derivative of ln 5x carefully, right? So this is, if this is f of x, then the derivative of f of x is equal to 5. And we know that when we derive this, we're going to have the derivative of f of x over f of x, which is 5 over 5x, which ends up as 1 over x. which means that if you have ln of 4x, it's going to end up as 1 of x. Ln of x is 1 of x. Ln of 3x will be 1 of x. So whenever you have any number in front of x, it just ends up as 1 of x. Okay, over here the x's cancel, and we're left with 1, and then that multiplied by 1 is that, so then we're done there. Alright, so here we go. Let's reason now the next function. I got y equals to, again, we will use the quotient for this one here. So if this at the top is given as a, then the derivative of this function would be 1 over 2x plus 1 multiplied by the derivative of the inside, which is 2. So we have 2 over 2x plus 1. And if this is b, the derivative of this is 4. So when I substitute it into this function, I'm going to have a dash b, which is the 2 divided by 2x plus 1 multiplied by b, which is 4x minus 1. And then I've got to subtract that. So let's see if I can put that somewhere at the bottom of this small space. Okay, so we're just going to use that formula a dash b minus ab dash over b squared. Yeah. So that's going to be 2 over 2x plus 1 times b, which is 4x minus 1 over 1 minus a, which is given as ln 2x plus 1 times the derivative of b, which is 4. So let's put the 4 in front there. And all of this is divided by the denominator squared, so 4x minus 1 squared from there. Quite a complicated answer, this one here. We got 4x minus 1. I can probably simplify this into a single fraction, 8x minus 1 over 2x plus 1. Minus 4 ln 2x plus 1. And the whole thing is divided by 4x minus 1 squared. It'll become 2x. This is, by the way, 8x minus 2. And then 2x plus 1, that's a single fraction. We could bring that into a single fraction and bring that into a single fraction in the last step here. So let's see if I can put that in there. So our final derivative, by the way, is given by multiplying 2x plus 1, or I could just bring the 4x plus 1 to the top, and I got 8x minus 2 minus 4 ln 2x plus 1 divided by 2x plus 1 multiplied by 4x minus 1 squared. Okay, and that would be the final answer. So the one thing actually we have to note here is that that common denominator is a bit tricky. I mean, I kind of squeeze it in there. But what we have here is we've got a fraction minus this number here. So I'm actually going to multiply this by 2x plus 1 before I can bring this fraction in. Right, to put this over 2x plus 1 like that. Okay, so I could simplify that further. Let's see if I can make a little space here on the left hand side, and I'll just finalize the last step there. Okay, so I've got 2 over 2x plus 1 as a common denominator, 2x plus 1. I've got 2 times 4x minus 1 over 2x plus 1 minus 2x plus 1 times 4 ln 2x plus 1 all over 2x plus 1. So I can have a common denominator all over 4x minus 1 whole squared. Keeping that denominator and then bringing it into the bottom would become 2 times 4x minus 1 minus 2x plus 1 4 ln 2x plus 1 all divided by 2x plus 1 times 4x minus 1 all squared and stuff.